Section 7.6, Example 3 on page 477, we have in Lesson 7.3, you learned how to find the distance between 2 points on a number line. To find the distance between 2 points in a coordinate plane, you can use the distance formula. The distance between 2 points, A, x1, y1, and B, x2, y2, so we can see A is x1, y1, and B is x2, y2, we have D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. The distance formula is based on the Pythagorean theorem. When you use the distance formula, you are really finding the side length of a right triangle. So we have A, B, and C, where A squared plus B squared equals C squared. So here, the distance of this bottom part of the triangle is x2 minus x1. The height of the triangle is y2 minus y1, and these represent numbers that we could use for A squared and B squared, and then to get D squared, we would add those two squares together, but to get just D, we would take the square root of all of that. So that is how the distance formula is related to the Pythagorean theorem. Example 3 says, what is the distance between U, -7, 5, and V, 4, -3? Round to the nearest tenth. I have added in the distance formula on the slide for us. We will let U, -7, 5 be x1, y1, and V, 4, -3 be x2, y2. Therefore, we have D equals 4 minus -7 squared plus -3 minus 5 squared. Minus and negative become a plus, so we have 4 plus 7 squared, and -3 minus 5 gives us -8. This simplifies 4 plus 7 to 11 squared, and -8 squared gives us 64. 11 squared gives us 121, so now we have 121 plus 64 under the square root, which gives us the square root of 185. If we plug this into a calculator, we get that D is about 13.6. So the distance between U and V, or the length of segment UV, would be 13.6. The work for this problem is written out on the next slide. And now I would like you to try homework number 6 on page 478. Find the distance between each pair of points. If necessary, round to the nearest tenth. X, -3, -4, and Y, 5, 5.